Hello and welcome to this week's What Were They Thinking? Among the variety of news items we have for you this week, there is an update on whether or not it's worth removing the thymus, and the possible implications it has for other pathologies. Detailed examination of how human fingers and toes grow, how preservation of food could have significantly altered human brain growth, particularly in terms of evolution, the implications of whether or not you're going to eat your plain white potato or a sweet potato of coloration, whether or not dinosaurs are the reason that we don't live until the ripe old age of 200 years old, China's first next-generation nuclear reactor comes online, the US is returning to the moon next month after nearly 50 years away, and self-healing metals. The timestamps for these and other news items can be found in the description box below. Let's start with talking about the thymus. The thymus is a relatively small glandular tissue found behind your sternum. That's the hard bony-like structure in the middle of your chest. The thymus doesn't seem to have much use in adults and is generally described as being rather useless. In fact, in many individuals, the thymus shrinks over time, whereas in children it's much larger. In animals at least, it's what makes up part of the sweetbreads. Of course, most individuals are not cannibals and obviously do not see it as a source of nourishment. Instead, what we may be observing, based on a retrospective study, is that removing the thymus increases the risk of cancer. Now, to be very clear about it, it is a retrospective study, and as such, its purely observational nature means that there is no definitive link that has been established. There are a few important caveats to this research. First of all, it is a relatively small cohort they're looking at. It's about 1,150 people who had their thymus removed, compared to 6,000 individuals who did not. However, the magnitude of the results, let's say, are noteworthy, primarily because those who had a thyrectomy, that is removal of the thymus, had nearly twice the risk of developing cancer. So, it's noteworthy, but it needs to be taken with a great deal of skepticism. This is why, at least in clinical terms, it's considered a priority to preserve the thymus at present, largely because if you are going to remove it and drastically increase the risk, you're better off leaving it there if you can. In further clinically related news, we have some concerns about what is arguably dementia and that it may be transmissible, although to be clear about it, the transmission here is a very low risk. Much like things like Creutzfeldt-Jakob disease or mad cow disease, it could be that dementia, given the proteins involved, are a kind of prion disease. However, this should be taken with a lot of skepticism. This does lead us to the, well, to be quite honest, not particularly significant explanation as to how they've gotten to this conclusion. The belief is that if the same tools are used on somebody who is undergoing neurosurgery and they have Alzheimer's or dementia, the same tools, if they're used again on someone else, could wind up with them becoming infected. But since most surgical tools now are effectively disposable, that seems to be an unlikely consideration. Instead, it's the other possibility that is more of a concern, and it's tissue transplants. The worry here is that if individuals receive a tissue transplant with someone with the misfolded amyloid beta protein, what is largely responsible for the development of the neurological conditions that we're talking about, they would become infected, or arguably could become infected, and we wouldn't know about it until years, if not decades later, given it takes a very long time for symptoms to develop. There are clinical examples of this occurring, although it's not definitively established if it is a direct cause of things like tissue transplants or something similar, but the concerns are there, and they have been gradually gaining traction over the last 20 years or so. Going from observational research that's less ideal to what is arguably direct original research that's more useful, and it's all down to the development of our digits. fingers and toes. It's what allows you to count to 10, or if you're so inclined, 20. The problem is, not everybody can count up to 5, let alone anything more, and that's because of how the limbs of a human grow. The hand, for instance, starts out as a relatively indistinguishable mass, and from that, the bones and muscles, tendons, etc., all slowly grow out, almost like petals on a flower, and that's eventually how you get a hand or foot. Knowing how these limbs, and more importantly the digits attached to them, grow is going to be important for things like IVF, developmental disorders, and problems with, development of a fetus. To use a relatively straightforward example, there are individuals who, due to the nature of how they've developed in utero, have webbed hands and feet. And that's because the fingers have not separated properly, and the cells that make up the tissues in between have not undergone the necessary apoptosis to free up the digits and allow their hand to operate freely with individual dexterous fingers. Understanding why and how this happens is where newer research is helping, and the newer research is largely only made possible by two things. One is newer technology, which has allowed us to visualize what's happening, but two, relaxation of the embryonic research restrictions. For the most part, you're only allowed to develop embryos up to 14 days, so 2 weeks. Anything longer than this is generally considered a no-go. However, some areas and some projects have been given permission to push that boundary, and in this case up to 8 weeks. And it's at that 8-week window that we see development of those features that define your limbs. Initially, the human embryo starts out as what is effectively just a mass of cells. They become a small sac of cells, and from there they become a rather amorphic blob. From that amorphic blob, you begin to see the limbs emerging out as almost like buds on a tree. And from those buds on a tree, you see the digits extend out like leaves or similar. This research has been matched against donated embryos that are between 5 and 9 weeks of development by individually isolating and identifying cells and mapping them to the appropriate coordinates, allowing for a visualization of what's happening where, when, and why across distinct time points of embryonic development. Shifting from uncertain research to very clear embryonic research to a leading standard of HIV research. It's an evaluation of the HIV prevention drug pre-exposure prophylaxis, or PrEP. The idea here is that it's meant to reduce the risk of being infected, and it's shown to be relatively effective at 86%, which, given the relative implications of being infected by HIV, an 86% protection rate is significant, and arguably a lot better than nothing at all by a huge margin. 86% to be clear. What makes this research, let's say, more significant, other than the ramifications for individuals who are at risk of HIV, is the sheer size and the breadth of the study. It's based out of England, and it involved 157 clinics, with 24,000 people involved. It was conducted over 3 years, and so we have a fairly good idea about what's happening. This is in some ways on par with clinical trial research, in that you're trying to figure out how much dose and what effect. That's already been done, and often it's not repeated, which is what makes these results more significant. To put this in a slightly different context that may help you understand what's happening, based on the trial results as such, if you want to call it that, if you were to live for 100 years, you would have a roughly 1% risk of developing HIV if you were in an at-risk group. Yeah, that's how much this protection is providing. It's a small percentage. Now, yes, if you were to, for instance, consider that most people's sexual activity drops off drastically after 70, it would be closer to 0.5%, but nonetheless, it's a significant degree of protection. Going on to food news now. although depending on how you view things, we may be touching on that in the previous article. The idea that preserving food may have significantly altered human brain development. Yeah, this does sound like a kind of stupid New Age idea, but the research is at least somewhat reliable. And we say reliable in terms of it makes a degree of logical sense, if not an exact degree of anthropological and anatomical sense. So archaeology and anthropology would probably have to go hand in hand, and given the way those two fight, it's unlikely to see happen. The researchers put forward that, if not completely, at least partially fermented foods, and the microbes involved in that process, have contributed to our brain's evolution. The idea is that, well, the human colon has shrunk significantly over time, or more accurately, the last 2 million years. And because the colon has shrunk, we have a reduced capacity to break down plant-derived food. Because of this, we need to partially digest or otherwise prepare food in order to be able to get the most out of it. For this to happen, the partial fermentation of food does exactly that. And to be very clear about it, this is something that should be taken with a great deal of skepticism, largely because it is purely hypothetical. And the authors do clearly lay out that this is a hypothesis that they are testing, well, claiming at least, not necessarily testing, and as such, trying to say that this is a definitive explanation, well, that would be taking this several bridges too far. The method that they think explains their hypothesis is that by fermenting foods in something like a sealed container, the same way you'd make sauerkraut, kimchi, things like that, you are then able to reduce the amount of fermentation that would need to occur within the human GI tract, which is what a lot of bacteria that is inside our GI tract will do. By minimizing the amount of work that they need to do and the amount of time the body has to metabolize that food for, we're able to reduce the volume of the digestive system. Because we can reduce the digestive system required for that, we can also more effectively absorb the nutrients and energy within it. This increases the available energy, nutrients, and so on that can be delivered almost directly to the brain. They believe that through the cultural and social practices of the early hominids that would pass on the process of preserving food through the process of fermentation, that they were able to effectively guide evolution and thereby increase the proportion of the body, and particularly the amount of energy demanded, focusing on the brain. They put this forward on the premise that if you were to look at various species and the not only proportion of the body that various organs demand in terms of the energy required, in humans at least, the brain makes up a large proportion, far more so than it does in other species that are similar. By comparison, the other species have a much greater demand from their colon, which means that our brain effectively replaces some of that demand. Shifting to other food-related news, although it's a pair of news items, they both focus on the same topic and they both present the same general controversy, which has raised some issues given how, let's say, exaggerated it is in some corners of the internet. It relates to the nutritional value of modern food and the fact that modern food is apparently less nutritious. Now, this is a somewhat dodgy area of research, largely owing to the problems of long-term data collection. So, the first news item is from Scientific Reports from Nature, and it talks about a shift in the mineral content of grain in India. They're primarily focusing on rice and wheat cultivars grown over the last 50 years. The other is a broad examination of what's happening across the world, and again, similarly focusing on grains. Let's first look at the Indian study, and what they found can be generally summarized as the mineral content, and particularly metals, within the grains that they were looking at has decreased over time. Now, this would be a worry in theory if what we were looking at was purely that the grains have decreased in their nutritional value. However, what they've associated this with is the choice to, well, for lack of a better phrase, selectively breed, and this is probably the most appropriate term, the grains that they're growing to grow quickly and produce the necessary content as fast as possible with the minimum of risk. This means, for instance, shorter wheat stalks, rice that is going to survive in slightly drier conditions, and so on. The argument is that because they grow better and faster, they don't have the opportunity to necessarily absorb and therefore hold on to the necessary mineral content, or at least the desired degree of mineral content. Now, it is noteworthy that although things like rice and wheat as a carbohydrate make up a large proportion of the dietary intake in terms of calories, they're not generally seen as the primary source of other macro and micronutrients. As a broad rule, the necessary and desirable nutrients that are missing from these staples are what would normally be obtained from a more diverse diet. Therefore, the loss itself is not a major problem. There is, however, the argument to be made, and the authors do write this in their conclusions, that reintroducing these favorable alleles, either via modern breeding processes, such as genetically modifying them, or similar, could help to, let's say, fix this profile. Although it would also be possible that you could simply modify these grains, such as rice and wheat, to have the necessary vitamins that you're after, or to increase their absorption rate, such as what was done with golden rice. Of course, there is a significant caveat to the need for this, and that's based on how the authors reached the conclusion that they have. They relied on modeling the available data that they have out to 2040. This means that they assume that the current projections they have will continue on for the next 17 years. This means that we're going to continue to see the decrease for 17 years, but that's a lot of speculation, which is a problem in and of itself. And it does mean that what they found might not hold true, given that there are possibly significant changes between now and then. This does bring us to the counterpoint, and the counterpoint is actually applicable as much to their research as it is to any other. That is, a lot of this data has been collected over a long term. For instance, the period of data collection for that previous study was 50 years. There are, however, significantly longer-term studies. For example, there is a 180-year running study. This is known as the Broad Book Long-Term Experiment. That study shows us why predictions for results like this, particularly based on the way they've done theirs, probably can't be relied on, and for very good reason. The Broad Book study is able to collect data for 180 years, so theoretically this is a great study to rely on. After all, we're looking at an incredibly long-term data collection process. It means you should have loads of information to rely on. But, and this but is incredibly big, that data has been collected over 180 years using different cultivars, different samples, different times, and all sorts of other issues. For example, introduction of synthetic fertilizers occurred only in the 40s through to the 60s in some places. Prior to that, you had use of manures. We don't know if they were practicing organic practices, which are bullshit. And there are all sorts of other problems. And that's just at the agricultural level, let alone the analytical level. The quality of the analytical techniques has grown exponentially since this experiment first started. Where originally you would be relying on very crude devices and methods to find out the concentration of various things within the grains grown, nowadays we have incredibly delicate and very, very sensitive technology that allows you to pinpoint exactly how much of something is in the soil, crops, and so on. It allows you to know a lot about very little. And that's the important thing here. We don't necessarily have data that is comparable to what we need today from 180 years ago. The other concern with this is that a lot of research into things like the quality and nutritional value of food especially over the long term like this, relies on existing datasets or tables. Now, some of these are good, a lot of them are okay, but they all have major limitations, and you often struggle to be able to compare them on an apples-to-apples basis. And that's again based on that original issue of, what are you actually comparing? Are they the same cultivar? So for example, are they growing exactly the same variety of wheat in that field today as they did 180 years ago, or even 50 years ago? It's very unlikely. And so, you don't even know if it's the same wheat you're going to be comparing, as an example, if it's from the same period of harvest, if it's the same conditions. How do you adjust for that? And there are all sorts of other problems that come up. And in some cases, such as that with the Indian study, we don't know if the grains or any other food for that matter was processed prior to analysis. Although in the case of the Indian study, we do know that the rice grains were milled and polished. And this means they did not have their husk on them. Because they were hulled, you've now taken away a large percentage of the mineral content of said rice strain or cultivar. It's why brown rice is generally considered more healthy than white rice, partly because the germ or husk has differing quantities of fiber, but also because of things like minerals, like the metals that it's now not having enough of, arguably because you have just removed the vast majority. A problem that is just as applicable to the, newer studies that come out quite regularly as it is to the older studies. This leads us to the same sort of problem with regards to white potatoes versus sweet potatoes, and claims that it's, not as healthy for you, and yeah, it's kind of a apples to oranges scenario. You can't really compare an apple to an orange and say that one is arguably better than the other for you, because they are different food. And not just that though, there is a wide variety of apples and oranges out there. As such, trying to say that one is necessarily better than the other for you is like saying that this random roll of the dice is better than this other random roll of the dice. You don't even know if they're related to each other. This is where the research gets to be very questionable in a lot of these cases, and especially when they get a lot of media attention, where suddenly people are shouting that such and such is bad for you. No, you don't actually need to worry about this so long as you have a reasonably balanced diet. That's because any deficiencies in one food group generally get made up from another food group. This is why, although theoretically you could survive on nothing but lettuce, you would have to eat so much of that lettuce that it would be, frankly, liable to see you explode. By the contrast, you can't eat certain food groups anyway to excess because they don't have what you need. For example, rabbit meat. There are certain contents, particularly vitamins and minerals, that just aren't present in adequate quantities, that by the time you finish digesting it, you've actually seen a net loss in those vitamins and minerals. This is why a balanced diet is necessary, and any claim that one particular food, such as potatoes versus sweet potatoes, has a winner is simply bullshit. And then of course there is the issue that, as mentioned, you have a wide variety of potatoes. You also have a somewhat wide variety of sweet potato. As a result, most research only focuses on one of each of these. For example, white potato versus orange sweet potato. Okay, but there are red potatoes, white potatoes, purple potatoes, and a bunch of other potatoes. There's also purple sweet potato, white sweet potato, and orange sweet potato. Yeah. And of course there are further issues again, much like with the Indian study where they hulled their rice, and we don't know if they've been peeling these potatoes or sweet potatoes. Yeah. That's enough ranting about bad research that's been blown out of all proportion. Let's shift to something that's arguably, at least, more reliable. And that is being able to trace the origin of corn or maize back to its origin, or at least as close to the origin as we can realistically get. And we know that it's roughly 5,000 years ago, and originates in Mexico, although the origin's not really in any real question, as that's been well known for quite a while. It's when it was made, and to a certain extent how it was made. Corn is one of the world's oldest grown crops, and arguably one of the widest grown crops. That's because it's fairly resilient to most of what we're going to do to it, and given how much time we've had, we've been able to develop some pretty resilient varieties of corn. All of that work to develop those resilient kinds of corn has been derived from just one particular cultivar, first developed 5,000 years ago, and it's a hybrid of several other cultivars that were growing at that time, and it tells you just how important and influential that one particular variety has been. It would appear that although yes, the vast majority of the genome of modern corn can be attributed to one particular variety, it's been found that about 20% of it can be traced back to a specific, independent lineage. It is this second lineage that was introduced about 5,000 years ago, and it would appear that that particular second lineage introduced is present in all the corn varieties we see to today. Shifting to other news, and this time largely looking at evolution and the adaptation of humans, and for that matter other mammals, to the presence of dinosaurs, and how this may be what has limited our lifespan. Yeah, this is another hypothetical, but at least this hypothetical isn't making the same kind of crazy claims, at least not in the same way, as the earlier study did. The idea here is that there is a bottleneck in how long mammals can survive and how quickly they grow versus reptiles in particular. The argument here isn't actually that different from what we see with some other species on Earth now. The fundamental idea is if you breed really quickly and have lots of kids, you might be able to pass on your genes and therefore the species will survive, because at least some of them won't get eaten by dinosaurs. Yeah, that's the gist of it. The downside to this approach is that because we need to breed very quickly, we also need to discard the genes that are responsible for extending our lifespan. Again, this kind of makes sense. You want the, offspring to grow up very quickly so that they in turn can have lots of kids that might or might not get eaten by the dinosaurs. Importantly here though, the time frame we're talking about is well before mammals actually gave rise to monkeys and apes, let alone gave rise to humans in particular. The research does have a little more bases in reality than just the hypothesis though, and that is looking at what is called the Eutherian mammal lineage, a period that mammals corresponded with dinosaurs, so they coexisted. There was a loss of certain enzymes that would deal with damage caused by ultraviolet light. Just about every single mammal, and even monotremes such as the platypus, lack at least one of these enzymes, and as such, there is a greatly reduced ability to repair damage to DNA in particular caused by UV light. The hypothesized reason for this happening is that, humans, more accurately mammals in broader sense, had to shift to a more nocturnal habitat and lifestyle in order to avoid dinosaurs that would eat them. And because of this, we didn't really need the UV light correcting enzyme because we weren't exposed to UV light. Kind of like those people who never leave their house except to get an Amazon package. Except in this case, the Amazon package was a dinosaur trying to nom on you. Shifting to news that's slightly more promising, and news for the best of boys, a new drug could extend the lifespan of larger dogs. Now, this is arguably kind of depressing, but the bigger the good boy is, the sooner they'll die. Yeah, little dogs will survive for a much longer time frame than big dogs. Sadly, this means that your woofer is going to find itself dying much sooner if it's larger. For example, a husky, Doberman, Great Dane, a Shetland pony. This is where a new drug has been given a sort of go-ahead for clinical trials, or more accurately, the results now require clinical trials in order to be able to get any kind of approval in place, and the FDA is looking to do just this. More specifically, the FDA has said in communication to the company involved, that is Loyal for Dogs, that their data is sufficient to show a reasonable expectation of effectiveness. This leads to them getting a conditional approval. Conditional approvals are what is a requirement for a clinical trial of any kind. It's effectively the FDA saying, look, you've got enough data now that we don't expect you're going to kill whoever's involved. So good. The drug itself is going to be used for dogs that are at least 7 years old, if not older, and weigh at least 18 kilograms or roughly 40 pounds. The way this drug works is that it targets a hormone called the insulin growth factor 1. This has already been known to be associated with aging and longevity in certain animals. By targeting this and limiting its activity, they believe it will help. This is why very small dogs can live up to 16 years and very big dogs as little as 7 years. But we're not entirely sure just how it works in terms of the observed effect. What we do know is that large breeds have up to 28 times the level of activity by this hormone than small dogs by comparison. This means that you may be looking at having your best friend around for a much longer time frame. However, there is one major caveat to this. Larger dogs are prone to a number of other complications, particularly as they age. This does mean that, for example, German Shepherds or Alsatians, depending on where you are, may have a greater risk of things like hip dysplasia the longer they live, which does raise a concern about the quality of the dog's life versus the longevity of the dog's life. Shifting to technology news, and we have China's first next-generation nuclear reactor. Although hopefully not China's first ever Fukushima or Chernobyl. The new reactor is slightly different to the conventional design, where a conventional nuclear reactor relies on water being turned into steam and going through a turbine to generate power, and then that steam being cooled down in a large cooling pond or tower. This relies entirely on helium. The benefits of relying on helium versus relying on water is that, particularly in parts of China, which are experiencing a drought at present, you don't need to worry about water. Therefore, those areas that are experiencing drought don't actually need to worry about having a constant supply of water that they just don't have. Particularly important if you're creating, or in this case have built, a 200 megawatt unit. Yeah. The other advantage is that this is a gas-cooled reactor, which does make it somewhat easier to operate. Having already operated for 168 consecutive hours and not exploding, which people would likely have already noted, it's been given the approval to go ahead and run permanently now. The other important, let's say, improvement of this reactor over others is that it doesn't require electricity to trigger the safety mechanisms. Yeah, that seems like a rather obvious thing given that it is a power plant, and when the power goes out and you don't have safety mechanisms, you wind up with a massive problem like Chernobyl. Unfortunately, older systems didn't actually take that into consideration, which is what happened with the Fukushima plant. In this case, because it doesn't rely on water in particular to cool it, it's able to shut down automatically. The only major worry with this particular nuclear power plant is that, well, to be none too delicate about it, it's in China, and China has a problem with tofu-drug construction. That is where construction is done so cheaply, so dodgily, and in such a bad way that it can literally crumble like tofu. Something you don't want to see with a nuclear reactor. In other reactor and energy production news, we have for the world's biggest nuclear fusion reactor. Where this differs from China's reactor is that they're relying on fission, that is the breakdown of nuclear material to generate heat, or more accurately energy, and then heat from that energy. Fusion takes something and combines it. Now, combining things, like for example melting something in a pot, is the same fundamental idea, but you introduce energy for that to happen. That's a net loss of power. Nuclear fusion to generate power is a bigger challenge. In order for this reactor to work, What they need is a massive plasma swirling around in what is a donut-shaped container called a tomahawk vessel. This plasma swirls around in it at 200 million degrees Celsius, somewhere around 350 million degrees Fahrenheit. This ridiculous temperature is necessary to take the hydrogen that's within it and have them theoretically fuse together to produce helium. This would, in doing so, release energy in both light and heat. It's effectively a mini-sun. What is slightly more disconcerting is that this reactor will not be the largest on Earth for very long. It is what you could effectively describe as a prototype of a much larger version called the International Thermonuclear Experimental Reactor in France. The challenge at this point will be to see whether or not the amount of energy going in is exceeded by the amount of energy going out on the scale that they have created. The upside, which makes this whole project worth the time, effort, and frankly ludicrous amounts of money that have been thrown into it, is that it produces a far less radioactive waste than what you would get from a fission reaction, but also there is almost no risk of catastrophic failures, like, for example, Fukushima's accident, or Chernobyl, even something like Long Island. Next we go to, astrological news, and that NASA is finally going to return to the moon. NASA has basically taken the whole "I'm going out to buy a pack of cigarettes and a bottle of milk" approach with the moon for the last 50 years. The Apollo mission was the last time the United States landed on the moon, and unfortunately, that's pretty much the end of it for now. We haven't gone back since, and we haven't seen anything exciting. There's been no more movies with Tom Hanks, and there's certainly not been any real developments. All we've been able to do is take advantage of what was built there way back when. On the 25th of January 2024, we should have a craft landing on the moon. This development has several facets to it that are worth noting. Other than the fact that, landing on the moon again, it's a private company that is running this. Yeah, the private company, the American company called Astrobotic, will send their lander named Peregrine to the moon's surface, and what it will be doing is studying the lunar environment, in the hopes that NASA's Artemis missions, which should be manned, will have a better idea of what's going to happen. There is, of course, the apocryphal quote, which regards the questioning of an astronaut just prior to launch about how they felt. The astronaut's response being, "How do you imagine I would feel sitting on top of a massive quantity of rocket fuel that could explode at any time, produced by the lowest bidder in the quickest time imaginable?" Although apocryphal, that quote does have a certain bearing on how much success we've had so far, and that is about half of all attempts to land on the moon have failed to date. Although it is worth noting that we're talking about both lunar landers and manned missions. So there is a lot of them that have gone, and a relatively small number of human casualties have occurred. Shifting to technology and engineering news, we have sort of a self-healing metal. Yeah, this research isn't exactly new, as the original research was published way back in July. What's worth noting here is that we have a slightly better understanding about what is happening. Although, again, we're going to hypothetical explanations, not actual explanations. The theory behind this, and again, remember, hypothetical, is something called cold welding. That's when the metal ions get close enough together that the individual metal ions get tangled together, and the atoms effectively become bonded that way, although it does require very narrow gaps in between them. And it's one reason why the cracks appear and disappear in the metal. Rather than just healing as a single piece, it more shifts the damage to different places by changing the structure of how the metal is, deformed. And finally, we have, again, a somewhat controversial article, this time arguing that science shows that we don't have free will. Well, more accurately, that's what's being debunked by this response from the conversation. it is worth us pointing out that the book itself has received attention, is how that a book is being responded to that we're particularly discussing in this video. If we were to oversimplify the premise of what's being responded to, it is that given that you have a body that has a specific set of genes, your brain is wired in a particular way at a given time, and that there are predictable cause and effect relationships between all of these things, you don't actually have the ability to control what you're going to do, since the blueprint upon which you are going to respond to the world and the ways in which you can respond to the world are limited. You don't have the ability to determine your own outcome. Yeah, it's one of those weird books that basically tries to say that people aren't responsible for what they do, not because there are underlying issues, but because we have no control over our lives. Yeah, something says this is bullshit. While we're not going to go into the depths of the philosophical debate to be had here, there are at least a few things that can be said reasonably clearly. First of all, we have the definitions being used, and the fact that language needs to be defined for this is sort of nonsensical, as there's pretty much a clear understanding about what these things mean. The second issue is that, well, most of what they're arguing is an A or B scenario. That is, you can either have one or the other outcome. There is no ability to say that these are the possibilities in between A and B. Which, again, given that we're talking about, well, humans to start with, and humans are ridiculously diverse and at the best of times uncooperative, yeah, you're not really working very well within a structured system here. It just doesn't work that way. The article and the conversation goes over a great deal more of the issues around this debate, and in terms of a purely interesting read, it's worth having a look at. But it isn't science. It's just a bizarre attempt by a neurobiologist from Stanford to make money and derive fame from associating their work with something that sounds kind of new age and hippie-like. That's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. Please do post any comments, questions, or suggestions you have below.